All right, so this is going to be a video. It's basically going to be like, sort of like a crash course introduction to algebra. And if you haven't done it ever, if you haven't done it in a while, this should hopefully help you out. So there's really three things I kind of want to go over here. And as you can kind of see right up on the board, the first thing is about counting numbers, positive numbers, negative numbers, what happens if you multiply these things, divide these things, add, subtract, everything, like underneath the sun with it. The second thing goes with fractions. So it's a continuation of counting, except now you have to start worrying about what are called the numerator and denominator. I think everyone pretty much knows what I'm talking about with that. And lastly, it's what we're trying to do with algebra, which is solving equations. And now, in addition to numbers, you're going to start throwing in letters and how those letters are basically variable placeholders for whatever it may be, and how to pretty much solve them. So this is pretty much the plan. We're going to go from counting into fractions, right, into solving equations with all those things combined in it. So the first thing I kind of wanted to go over was for counting. So when we think of counting, we're going to count money. We're going to count the number of cars on the street. We're going to count a lot of stuff. There are basically four operations that you do with it. There's addition, subtraction, multiplication, division. And so in this case, what we're going to is you can kind of see there's a number line up, and there are two types of numbers, specifically in algebra. There are positive numbers and there's negative numbers. So you can do these four operations with these two types of numbers, and you're going to get a different outcome for each depending upon what. So let's go over here and let's go find out. So let's just say with addition, let's go easy. Addition. So if we're going to add, let's just say two numbers together, we're going to get a different result if we add two positive numbers together compared to two negative numbers together compared to if we choose one positive and one negative. If you understand these simple cases, you should be able to go and explore larger domains with this. So for example, let's just do the first case where you have two positives, right? Two positives. Let's put this in brackets here. Two positives. All right. So two positives. Let's choose any two arbitrary numbers. Let's just do 2 plus 8. All right. So this is simple arithmetic. Most of you probably know this in your head, but this is what's going on behind the scenes. So instinctively, we know that 2 plus 8 is 10, right? So how we essentially do this is we're going to go on the number line here. We're going to go up to 8, and then we're going to add two more jumps up, which gives us 10. And because these are two positive numbers, we're going to keep going into the positive direction, because a positive 8, we're going to be getting a more positive number. That's why the 10 has a positive sign to it. It's pretty straightforward, pretty easy. So let's change it up. Let's just do two negatives now, right? So two, it's terrible G, two negatives. All right. If we were to do two negatives, let's do the same two numbers, right? -2, -8. So there's a few things you can do here, but essentially what you're doing is, let's go on the number line again. Let's go to a -2. We are going to subtract 8 from -2. So essentially what that means is we are adding a -8 to this -2, where this number should be getting more negative because we're adding, there's nothing but negatives here. So this number should be getting more and more negative. So we're going to start at -2, and then we're going to add on an additional -8 to it. And you'll end up that you'll find out that this answer is not too different from the other one. It's just -10 in this case. So it's easy. It's very easy to do and very easy to understand, but this is what's going on with the number line. So where it starts getting trickier in this case is when you have one positive and one negative. So let's do the special case of go up here. I'll just write this as notation: one positive and then one negative. All right, so let's just do Let's just do -2 plus 8. So in this case, what you're going to be doing is you're going to start off at -2, but you're going to be adding a positive 8 to it, which means you're going to go into the positive direction 8 units. So if you start that here, you're going to go 1, 2, 3, 4, 5, 6, 7, and 8. So our answer should be a positive 6 because we're on the positive side of the number line. This answer could very easily change if we were to say, let's just do a positive 2 and -8, right? So let's have a positive 2. When the sign isn't here, it's assumed that it's positive. So we're going to start off at positive 2, and we're going to subtract 8 units from it. 1, 2, 3, 4, 5, 6, 7, and 8. So if you notice, we actually got a -6. And so that answer isn't too different from the positive 6 that we received before. When you start playing with the signs, you notice that there's some sort of symmetry to this number line. So that's the reasoning for it. It's not too hard when you get it. So that's the first case, which is addition. So if you add two positives together, you're going to get a more positive number. If you add two negative numbers together, you will be getting a more negative number, a larger negative number, if that makes sense. So this leads us to subtraction. So let's go with subtraction. All right. So for subtraction, there's actually a rule that I should state before. And really what this is to do with signs. Adding numbers and multiplying numbers is pretty much almost everyone knows, but everyone pretty much gets very messed up when it comes to the signs of this stuff. So when you have positives and negatives together, a different combination of them will actually change the sign of each. So let's just say with, and this comes with multiplication, but as you'll see in a second, if you give me a second, we'll see that we're actually be, in a way, multiplying in a little bit, you'll see. So when we are multiplying signs, and again, my handwriting's awful. We're multiplying signs. I'll just write this in sort of a very awful notation. Two negatives multiplied together. So two negatives multiplied together. Let's just say that that's awful. Let's actually make this better. So let's just say we have a negative number times a negative number. The sign, so this is a negative, and this is a negative number. Two negatives multiplied by each other will give us a positive number. This is a positive number. If you have a negative number multiplied by a positive number, you will be getting a negative number. And then if you do a positive number times a positive number, you'll be getting a positive number. So kind of understanding this for a brief second, let me throw this away here and let's see what we got. Okay, so when it comes to subtraction, let's throw up some numbers and see what happens. So we have, let's just say -2 subtract, let's do subtract a -2. Okay, so what we want to know what exactly this equals. Okay, so here this problem looks a little weird because we have parentheses, and really what this is stating, you can rewrite this problem as stating we're going to have -2 subtract, and this whole parentheses is actually multiplied by a -1. It's unstated, but it's there, times -2 is equal to. So before we can subtract these two numbers together, we need to basically multiply this together because there's a certain order of operations, which I'll go over in another video or later on. And so we need to multiply these two numbers together before we can actually subtract. So what this is going to leave us is we have let's look at it this way. We have a -2 subtract. We're going to have a -1 multiplied by a -2. So as we said here, a negative times a negative is equal to a positive number. So that means we're going to keep this -2 out front here. We have a negative number times a negative number, which gives us a positive number. So we know it's positive. 1 times 2 is 2, right? Cool. So now we're ready to subtract, even though our sign has now changed. And as you can pretty much tell, -2 plus 2, they cancel out. You're left with 0 as your answer. So that is a quick overview of that for subtraction. So let's just do another one here just to make sure that we're good. So we can very much do, let's just say, let's just do 7 minus a minus, another parentheses, minus 7. Okay, this one looks weird and a little bit harder, but as you can kind of see, as you'll see in a second, as long as you kind of stick to this plan, you know these three things: negative times negative is positive, negative times positive is negative, positive times positive is positive. You can pretty much figure this out. So as you can see here, there's a lot of parentheses, and what we're going to do, just like in the last one, we're going to be multiplying, but we're going to be multiplying inside out. So we are going to be sticking to this guy here in particular first, and then we'll do it the outside parentheses. So as this negative here states, there's a -1 being multiplied by this -7. As we said earlier, that will give us a positive number, and we know that 1 times 7 is 7, so it's going to give us a positive 7. All right, cool. 7, I'll just write that like that. And we're going to rewrite the bigger parentheses around it, and I'm just going to rewrite the problem. Cool. So now we need to do this thing again. Now we have a -1 being multiplied by the parentheses of this positive 7. That will just give us a -7. I believe that's kind of stated. So 7, it ends up being 7 subtract 7, which is just 0. So pretty easy to understand. And that is pretty much takes care of multiplication and the subtraction as well. So what we're going to go on to next is division. So division. Division. So when it comes to division, division is the reciprocal of multiplication, and you'll see this when we get to fractions here in a minute. So let's just say I have a number. Let's just do a quick equation. So let's just do 5x is equal to 10, right? I want to solve for x, which we'll find out later. So we're going to divide both sides by 5. Here's where some rules come into play. Any number, so if you see on the left-hand side, we have 5x divided by 5. Any number that is over itself is equal to 1. So this is going to cancel out. It's going to equal to 1 multiplied by x. And on the right-hand side, we have a fraction. And I don't like fractions, so what we're going to do is we're going to reduce it. We're going to say 10 divided by 5, which is just simply equal to 2. Okay. Not too bad, not too harsh. We're going to redo this equation again, but we're going to switch up the signs on it because there's some stuff that happens. All right. So let's do this again. Let's do 5x. All right. So what I would like to do is we just did the case where both numbers on both sides are positive. You're going to be getting a positive number. Let's do the case where you have one negative and the other's positive, right? So in this case, we have a -5x is equal to 10. If we, again, we want to solve for x, make sure it's just by itself. We don't want 5 of them. We only want one of them, right? And we want a positive one of them, not a negative one of them. So we're going to divide the left-hand side by a -5. We're going to divide the right-hand side by a -5. Okay. Again, any number over itself, positive or negative, is equal to 1. So on the left-hand side, this -5 over -5, that goes, and we just get x. X is equal to 10 divided by -5. Well, the number portion is still the same as in our last video. as in our last problem. So 10 divided by 5, positive or negative, is still 2, right? Because there's that sort of symmetry that you were able to see from the positive and negative. So it's still 2, right? Now, essentially what we have here is we have a positive 10. It's unstated. We have a positive 10 divided by a negative 5. The negative wins. You can go more into it about it, or you can just accept it. When divided together, if you have a positive divided by a negative, the negative wins. So it's going to be a negative 2. And similarly, let's just say we had a equation here where we had 10 over 5, and we had the negative was in the top portion over a positive number. The negative still wins. It's the same thing. Same thing. Okay, so that is kind of the rules when getting for division. Like I said, it's very quick, very crash course like. Typically, I would hopefully like to spend a lot more time with this, but anyways, hopefully you get the main portion of it. Anyways, so I'd like to go on next to fractions. So when it comes to fractions, the definition of a fraction is, let's just write up here. I'll just do it in black. So definition. It is any number, let's just call it any number A. I'm going to speak it very, A could be any number divided by any number B, where I'll write down here A and B. I'm going to go math right here, are elements of this. Looks really funky. What this is just saying is that they can be A and B can be 0, 1, 2, 3, 4, 5. Keep going up by ones. They have to be even whole numbers or integers. That's the definition. So you can't necessarily have you could, but for a basic algebra case, it's not really preferred. So that's the math way of kind of looking at fractions. So let's get rid of that so it doesn't necessarily confuse you. So, okay. So when it comes to fractions, you have a top part and you have the bottom part, right? Both of which are numbers. Okay. And they're probably going to be equal to something, whatever. Their specific names are the numerator, and the bottom part is the denominator. I messed that one up. Denominator. I'm not even sure if my English is correct. It's late. So if you hear me referring to the numerator, denominator, that's what that means. Another term that is probably very useful is what's called the reciprocal. So reciprocal. I don't even know if I'm spelling that right. And so what the reciprocal is let's just say we had a fraction. Here's an example. So let's just say we had a fraction 1/5. Okay, cool. Sometimes basic algebra problems or algebra problems in general will be like, what is the reciprocal of it? And all that means, flip it. So whatever's on the top, bring it down to the bottom. Whatever's on the bottom, bring it to the top. So the reciprocal of 1/5 is equal to 5 over 1. And we know that any number divided by 1 is just itself, which is just 5, right? So there's that. Now that we know about the numerator, denominator, and the reciprocal of fractions, which is just flipping it, we need to learn the operations, the 4 operations: addition, subtraction, multiplication, and division with fractions. And this is where people really get tripped up. Typically students in middle school and high school always have an issue with this part, all right? So don't feel bad if you don't get it. There's a lot of people who don't understand this. So let's just do let's just do the easy ones first. So in my opinion, I think multiplication and division are easier, and you'll actually find out that division is the reciprocal of multiplication, right? So remember, reciprocal means you flip it. So that'll come into play here pretty soon. So let's just do multiplication. Multiplication. Cool. So multiplying fractions. Let's take any two fractions here. Let's just do 1/2 times 1/4. We want to know what this is equal to. Okay. The nice thing about multiplying fractions, whatever the numbers are, you multiply across in the numerator, the top, and you multiply across in the denominator, the bottom, right? So what this turns out to be is we're going to multiply the two numbers in the top, the numerator, together. So 1 times 1 times 1 is 1. We're going to multiply the two numbers in the denominator together. So 2 times 4 is 8, right? So our final answer, 1/8. Easy peasy, pumpkin squeezy. So that is pretty much multiplication, right? We will do a few more here. So I want to make sure that this is really understood. This is really hard for people. So let's just do 8/5 and 9/10. All right, 10/9, my bad. So so again, we want to see what this is equal to. We don't like two fractions. We want to make sure it's one fraction. So we're going to multiply the numerators together and multiply the denominators together. So 8 times 10 is 80. 5 times 9 is 45. So this is your answer. Now, when it comes to this point, a lot of professors or teachers, or sometimes if you're doing a test online, they want things in what are called the reduced form, and they just want everything reduced. So in this case, I kind of happen to notice I have two numbers. I have one in the numerator, one in the denominator. I have 80 and 45. I kind of know that there's another number that can go into both of those numbers. So I can probably find a simpler fraction to represent this same number. It's the same number, just scaled back, easier to understand. That's all we want, right? Because we're human beings. So what number can go into 80? What number can go into 45? Turns out that that number happens to be 5, right? So the question is, what times 5 is equal to 45? Well, that's 9. Right? And then what times 5 is equal to 80? And in that case, I will hand out my trusty calculator because I don't want to take up too much time. And I notice that that is equal to 16. And at which point I can kind of see that there's really no number that goes into 16 and 9. So 16/9 is my final answer. If I wanted to change this into a decimal, I very much could. I would just need to do longhand division and divide this out, and I would get some number. It would be something like 1.7 something if I had to guess. Anyways, so this is multiplication of fractions. The easiest one, multiply straight across. Okay. Next one we're going to be doing is division. And so as I basically said before, division is the reciprocal of multiplication. So division. So let's just do this guy here. Yeah. Let's do 1/2 divided by 1/4. Okay. So you can do this a couple different ways. And what you're going to do is you might see fractions in this form, or you very well could see them in this form. 1/2 divided by 1/4. Personally speaking, I think it's easier for me to visualize it if I do the second way, because I kind of understand what to do more there. I'll do it both ways so you kind of understand it. So here, what we're going to be doing is unlike multiplication, you can't just divide across, but you can turn any division problem into a multiplication problem. And we do know how to solve multiplication problems. So what we're going to be doing is we're saying 1/2 is divided by 1/4. We're going to be finding the reciprocal of the second fraction that is going into the first one, and then multiplying them across. So let's just see. Now we have, I'm going to write the problem over here. So we're going to go 1/2. We want to turn it into a multiplication problem. We're going to find the reciprocal of the second fraction. Remember, the reciprocal is just that number flipped, right? So the 4 is now on top and the 1 is now on bottom. Cool. And this hasn't changed the problem. You could look in other videos and figure out why, but ultimately, you want to just believe it hasn't changed the problem. So now we know how to do a multiplication problem. Let's multiply across. Excellent. So we multiply the numerators together. We multiply the denominators together. Numerators, 1 times 4 is 4. 2 times 1 is 2. So again, we want it in reduced form. So we know that 2 can go into both. 2 goes into 4 twice. 2 goes into 2 once. And we know that any number divided by 1 is equal to itself, which is just equal to 2. That's our answer. So that was the one way of doing that. I will write this in purple. So I'm going to do this problem again, but shown in a different form. And the reason why I do this is because this way is easier for me to visualize which fraction to find the reciprocal of. There's a lot of people that will they'll take the reciprocal of this fraction, the first one, and then they'll multiply straight across. But if you do that, you're actually going to get a very different answer. So which fraction you find the reciprocal of does matter. So in this case, we have 1/2 divided by 1/4. And so what I'm going to do is always take the bottom one. Take the bottom one, the bottom fraction, parentheses, find the reciprocal, which is 4/1. And we're going to do the same thing to the top, right? Okay. And now what we're going to do, this is turned into a multiplication problem. That's what the parentheses mean. And now we're going to multiply straight across, okay? And if you can kind of see it down here in your denominator, you have 1/4 times 4/1. And so what you're going to be getting is that these things are going to be canceling each other out, which means this whole fraction is over 1, right? And anything over 1 is really just itself, which means we can negate this completely. We can just forget it. So what really matters here is this top portion. So this should look very similar to this up here, the 1/2 times 4/1, which we know because we just did it is equal to 2. Now, if the second method helps you understanding how to divide, do that one. If the first one helps you more, do the first one. Just remember that you need to take the reciprocal of the second fraction that you do this with. Okay, so pretty much it for that stuff. And now what I'd like to do is for fractions. Let me see here. Now come the harder ones. So erase this stuff. Addition and subtraction. They are the same, but you have to be careful of the signs. And this is where every single person gets tripped up. So let's do this. Let's just do addition. Addition for fractions. So let's do our trusty old 1/2, and let's just say plus 1/4. So there's a problem here. Unlike multiplication, we can't add straight across, and that is because there is a rule in algebra that says in order to add or subtract fractions, goes for both, you need to have the same denominator. They need to have the same lower number. And in this case, they don't. One's 2, the other's 4, right? So how exactly do you do that? What you do is you multiply one or both of the fractions by another fraction in order to make them have the same denominator. So in this case, let me write this out, and I'll write this one in purple. So let's just say we have a 2 here. It'd be easier to make this 2 into a 4 instead of a 4 into a 2. So what we're going to do is we're going to do 1/2, and we're going to be multiplying this by another fraction of some kind to make this equal to basically have the denominator equal to 2. And let's just do this guy here. I'll keep this 1/4, right? And what we're going to be doing in this case is, what number can I multiply here to make 2 equal to 4? Well, that's 2, but I can't just multiply just by any random number over 2. It has to be the same number, and that's because technically we're multiplying by 1. We don't want to change the problem. So if you notice, 2 divided by 2 is 1. 1 times 1/2 is just 1/2. We haven't changed the problem. We're just playing around with it. So 2/2 times 1/2 plus 1/4. Now we have to figure out, okay, well, what do we do now? So we have a multiplication problem now, and then we have addition. When it comes to the order of operations, multiplication beats division. Kind of like rock, paper, scissors. There's an order which can beat something else, right? So let's multiply this guy out. So that's going to be 2 times 1, because we're multiplying across. So it's going to be 2 times 1, which is 2. 2 times 2, which is 4. And now we can add our fractions together because they have the same denominator. When you add fractions together, your numerators change, but your denominators do not. So 2 plus 1 is equal to 3. And you keep the denominators. So 3/4, right? 3/4. This is the same thing even for negatives. However, the sign for negatives ends up tripping up a lot of people. So let's redo the same problem again, except I will now do negative and see if we get a different answer. So let's just do negative 1/2 subtract 1/4. Okay, same rule applies. We still need the denominator on the bottom to go and be the same. So we're going to be multiplying the first fraction by 2/2. Nothing changes there. 1/2 minus 1/4. Nothing changes. We're still going to be multiplying across. So this is going to give us down here. So can we give us 2/4. Subtract 1/4. So what I like doing here is basically saying I like taking this negative sign and giving it to the second fraction. So what we're really saying here is 2 minus 1 all over 4, because again, they both have the same denominator. That's really what's going on. So 2 minus 1 divided by 4, we know that this is equal to 2 minus 1 is 1 over 4. So 1/4 is your answer. So again, it's not too bad, but you just have to watch out for your signs. It's a lot to remember. Again, it's a crash course. So there's that. All right, last thing is solving equations. So when it comes to solving equations, typically this is where we start introducing the alphabet into math. So, and we call them variables, and they're just placeholders for different numbers that we don't know about. And it's going to be using all the techniques that I've gone on so far, the accounting, the fractions, everything, addition, subtraction, multiplication of all those things. So going over it, in this case, let's just do, we got 2x plus 3 is equal to 0. And what we're asked to do is to find out what is x equal to. And what we should be asking ourselves is, what number makes what number could x be that will make this equation true? Because there's a lot of numbers that will make this equation false, right? I could put in 100 for x and I will get 203 is equal to 0, and that absolutely is not true. So, but there's only, in this case, there's only one solution, and there's only one number that makes this thing true. We're always looking for the truth. So what we're going to be doing first is, there is a order of operations, and this I should probably actually go over really quickly, do another crash course on it, and I'll do this for a second. There's something called PEMDAS. PEMDAS. All right. And so some people call this parachute expert, my dear Aunt Sally, and it's just an acronym for the order of operations on how to solve an equation. So in this case, P stands for parentheses, E stands for exponents, M stands for multiplication, D stands for division, A for addition, S for subtraction. So this is just your order of operations here. So as you can kind of see from above, let's actually rewrite this, but maybe let's just see. PEMDAS. Just keep that in mind. So in this case, we have a 2x. This is technically multiplication, so it's 2 times an x. However, we don't know what x is, so we can't multiply it yet. So we're going to go on to the next one. There's no parentheses. There's no exponents. Multiplication we can't do. Division we can't do. Addition, it's asking us to add. So we're going to do that guy first. But what we need to do is we need to get x alone. So what we're going to do is, and magic rule in algebra is whatever you do to one side of the equation, you also have to do to the other side, because you do not want to change your equation. Imagine that your equation is a scale. You need everything perfectly balanced. What you add to one end of the scale, you have to do to the other one. So in this case, we're going to subtract 3 from both sides. Subtract 3, right? -3 plus 3 is where your negatives and positives come into play. Turns out to be 0. So this cancels out at 0. All right, so now we have 2x is equal to 0 minus 3, negative 3. Cool. All right, we no longer have our addition, and we have a negative number here, but we want the whole goal is to get x by itself. So what we're going to do is we're going to divide both sides by 2. Divide both sides by 2. And we have fractions now. Any number divided by itself, 1. So now we get x is equal to -3/2. Cool. So it turns out that the solution to this equation is a fraction. Cool. All right, let's do more complicated stuff. Alrighty here. So what is a good one? What is a good one? It's a good one. Let's just do something like this. 4x plus 7 plus 6x is equal to 14. Cool. So just made this up, no idea what it is, and we are asked to solve for x. Now, what's different about this equation than the last one? We have multiple x's. And so when it comes to this stuff, what you should be looking at is, it looks like I have each thing here that's being added, summed up, added to the next thing is what is called a term. So we have 3 terms here on the left-hand side, 1 term, 2 term, 3 terms. And so we're going to put like terms together, and we're going to do whatever operations there is for that. So in this case, to make it easier, what I will do is I'll rewrite this equation, and I'll say 4x plus 6x plus 7 is equal to 14. So in this case, we can only add or subtract, multiply or divide things that are like each other or that are each other. So in this case, I can't add the number 7 and I can't add car together because they aren't of the same thing, right? But I can add 2 numbers together if they're just numbers, and I can add or subtract other things together. So in this case, we have a number times an x plus another number times an x. So therefore we can combine these together. So 4x plus 6x, in this case, your x's stay the same, but your numbers, you're going to add the individual numbers. So 4 plus 6 in this case is 10. It will still be multiplied by x's. So if I have 4 cars plus 6 cars, when I add the cars together, I should be getting 10 cars, right? Rewrite the equation. Plus 7 is equal to 14. Like the last one, we want to get x by itself. Let's subtract 7. right? 10x, and I'm going to do this in my head. I know that a positive 7 minus 7 is going to make this 0, and then 14 minus 7 is going to equal 7. And lastly, we're going to get x by itself. We want 10 cars. We just want one car, right? We only want one x, not 10 x's. So we're going to divide by 10 and divide by 10. And we get any number over itself is equal to 1. Okay. And our answer is equal to, it's written there, but x is equal to 7/10. Right? Cool. And there is that. That is a good, I think that's a pretty good introduction to that. Let me do some others. Okay. So let's do a harder one here. Let's just do x squared is equal to 4. So sometimes in math, they come across equations like this. Before, we're only used to x, where the exponent, where is being raised to, was raised to 1. That's why there was only one of them. In this case, the exponent happens to be equal to 2. So we have x squared is equal to 4, and we're still asked to solve for x. And so what we know we can do is we can take the square root of both sides and we can solve for x. So what we're going to be doing is this x squared here can also be written as x times x, right? And this is the definition of a squared root. It's equal to 4. And so if you can imagine it, we're going to take the square root of both sides in order to, and whatever you do to one side, you have to do to the other one. So in this case, x times x, the square root of it is just x, and the square root of 4, which the square root just simply means what times itself will give you whatever is underneath the square root. So we know that 2 times 2 is equal to 4, so we're going to get a 2 here. However, it's important to note that when we deal with the square root, it could either be a positive or it could be a negative number, right? And so this is your answer, and I will prove this to you. So our original formula was x squared is equal to 4. Now we have two solutions here. We have a positive 2 or a negative 2. And so I should be able to plug in either one and get the same answer if this is true, right? So let's just do 2. I plug in 2 for x. 2 squared is equal to 4. Well, I know that squaring means I'm taking whatever it is and I'm going to multiply it again. So this means that 2 times 2 is equal to 4. And we know that 2 times 2 is equal to 4. So 4 is equal to 4. So this one checks out. Cool. Let me do this again. So let's just do a negative 2 squared. And I'm going to, just for clarity's sake, I'm going to write this in parentheses here, is equal to 4, right? So we're going to take this entire thing, the sign included, and square it, multiply it by itself again, and hopefully it should be equal to 4. So let's just do negative 2 times, too many times there, times negative 2 should be equal to 4. And so again, when it comes to multiplying numbers, you can multiply the numbers, and we know that 2 times 2 is 4, but we have this negative sign here. And if you remember from a while back, a negative times a negative is a positive number. So let's go up here again. Negative times negative, that's going to be equal to a positive number. So we get a positive 4, and positive 4 happens to be equal to a positive 4. So this works out, right? Cool stuff. And I believe that is going to conclude my crash course for algebra basics.